Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. In the previous lesson or in the previous video, we have learned how to solve basic exponential equations. Today we are going to learn how to solve basic log equations, okay? So in exponentials 4.1, we saw that there is a property of equality for exponential functions. Here we see that there is a similar property for log functions. Let b be a positive number where b is not equal to 1. Let x and y be positive numbers. If you notice in here, the property says that if the bases are the same, right, we can just make sure that the x is equal to y, and we can solve it by making x is equal to y and solve for whatever the value of x is. Now, before I move on to the next or to an example, I need to make sure that we understand something here. Unlike exponential equations, I am reading on here, unlike exponential equations, we do not need to check our solutions. Any values for x that yield to a non-positive argument must be eliminated, okay? So in this case, whenever we have a number inside the parentheses, so let's say, for example, we have log of whatever base of a -2, for example, this has to be eliminated because this is what we call a non-positive argument. And if we actually put that in the calculator, it will be an error. It will be undefined. So we need to make sure that in any of our solutions, we will not end up with a negative in the parentheses. Yeah, we call that one for any values of x that yield to a non-positive argument, it must be eliminated. So again, we need to check our solution because a log of a negative number is undefined. It's error. We cannot have a negative inside the parentheses or a negative x value in the argument. So let us check. How do we do that? Okay, so we have here log with a base of 6. Yeah, log base 6 of 5x minus 2 equals log base 6 of 2x plus 13. So let me take a look first. Do they have the same base? So it looks like we have a log base 6 on the left, and we also have the same log base 6 of 6 in the other side. So our property says we can do make x equal to y. So in this case, I'm going to do 5x minus 2 equals 2x plus 13, and I'm going to solve for the value of x. So what is that? I'm going to subtract 2x on both sides. Subtract 2x on both sides. I'm going to, let's do it one by one so that you don't get confused. So we have 5x minus 2x, so that is a 3x minus 2 equals a 13. And then we can really see that we have to add 2 on both sides, yeah? So that's 3x is equal to 15. And then, of course, we divide 3 on both sides. X is equal to 5. Okay, but I cannot say that my answer is x is equal to 5 because I need to make sure that when I plug in 5, I will not end up with an x value that is a negative, meaning that when I solve over here inside this parenthesis, it will not be a negative. So remember, how do we check? We do a left side equation, and we need to make sure that it's equal to the right side equation. So I'm going to plug in 5. So this is 5 times 5 minus 2. That is log with a base of 6. 5 times 5 is 25. 25 minus 2 is 23. So it's a positive number inside our parenthesis. Moving on, I have log base 6 of 2 times, what do I plug in? I've plugged in 5 plus 13. So log 6 2 times 5 is 10. 10 plus 13 is 23. So we have log base 6 of 23 on the left. We have log base 6 of 23 on the right. And since my left side and my right side are equal to each other, and there is no negative value inside the parentheses, our final answer would be x is equal to 5. Okay? Now, Miss, what if this was a negative number? If it was a negative number, I would have said no real solution. Okay, moving on. Do they have the same base? Yes, they do have the same base. So I'm just going to move into copying this. And then I am going to subtract 2x. I'm going to put that right in the middle of x squared and a 15. So I'm going to end up with x squared minus 2x minus 15 equals 0. Is this factorable? Because if it's not factorable, we have to do completing the square or quadratic formula, and that is really, really a lot of work. Okay, let's see if it's factorable. We're looking for two numbers. What are we looking for? Two numbers that when we multiply them, we will get negative 15. And when we add those two numbers, we have to get negative 2. I think there is one. Can we check this? Negative 5 times positive 3, negative 15. Check. Negative 5 plus 3 is a negative 2. So we have our pair. So x minus 5 equals 0. We will get negative 5. And again, we have to check these, into our solution if it actually works. Okay, so we have a positive 3, a positive 5, and a negative 3. So let us make our left and right. Actually, let's change the color for checking. So what do we plug in first? Let's plug in 5. So plug in x equals 5. So log with a base of 3. 5 squared minus 15 closed. Log 3. We have 5 times, backwards. 2 times 5. Okay. So this is log base 3. 25 squared is 25. 25 minus 15 is a 10. So it's not a negative, so we're good. Log base 3 of 2 times 5 is a 10. So we have it equal to each other. So the positive 5 would work. I'm going to put that in there because it works. Then let us plug in the next number, negative 3. Okay, so we have log 3, negative 3 squared minus 15. So log 3, negative 3 squared is a 9 minus 15, right? Negative 3 times negative 3. So log with a base of 3, and then we have 9 minus 15, we'll get a negative 6. And because this is a negative, that means that negative 3 is not our solution. And like, Miss, what? You don't have to do this? I don't have to do that because I already know that one of them yield to a negative x value. That means that it will not ever work. So my final answer is just equal to 5. Just 5. Okay. We're good. That's it. Moving on to the next two examples. Okay, hopefully that wasn't difficult. Before I go to the next example, I would like to read this part over here. Let me highlight this. Okay. Recall the power property of log covered in exponentials 2.3. This property says that we can take a number in front of a log and move it to become the exponent of the argument. That is, when you say argument, that's the number inside the parentheses. Okay? That is, we can rewrite 2 times log of x as log of x squared, because that means I can take these and put that in there. The property for equality for log functions does apply to the resulting equation. Log of x squared equals log of x plus 2. Okay, so for here we're going to apply, but I'm not going to use this example because we already have an answer to that one, right? So I'm going to use something that we don't have an answer to. We have 2 times log base of 14 of x equals log base 14 of x plus 30. Notice that your bases are the same, so we can just ignore the log and then focus on the numbers. And remember the property, I can take this too and I put that as an exponent. As if it was an exponent, I could also take it and put it in front of the log. Okay, same exact property. So then I now have an x squared equals log, I don't have to put log, x plus 30. And just like that, you have a quadratic. So I'm going to subtract x and subtract 30. And I'm going to have x squared minus x minus 30 equals 0. Not bad, yeah. So this is x minus 6 and x plus 5, right? Because negative 6 times 5 is a negative 1. Sorry, negative 6 times 5 is negative 30. Negative 6 plus 5 is a negative 1. The number in the negative x. Okay, so again, if I'm too fast, you can always pause the video, rewind the video, rewatch it over and over again. Okay, so I am going to have a negative 5 and a positive 6. And remember, we have to solve that. We have to plug it in to see if it works. So let us plug in either one first. You can plug in negative 5 first, or you can plug in positive 6. It doesn't really matter. What matters is you plug them in both left and right. Okay, let me plug in positive 6. X equals 6. So I have 2 times log 14, 6. And then remember that I could, let me put an arrow, I could take these and put that in there. So instead of 2 times log base 14 of 6, I could write that as log 14 of 6 squared, which eventually gives you a 36. Okay, moving on. Log base 14 of x plus 30. So 6 plus 30. Ooh, nice. They are both equal to each other, and there's no negative in the argument, no negative inside the parentheses. So 6 works, and because it works, I'm going to put that right there. Moving on, let's plug in negative 5. Let's see if negative 5 works. We have 2 times log with the base of 14 times negative 5. We have a negative number inside the parentheses, so I am going to stop. Negative number, negative, actually we can call that one, instead of like saying, because I just put negative, yeah, we could put that as a negative argument. Let me put that one also in the other side. Hold on. Negative argument. Okay. Now, you might have a question, miss. How could it be a negative argument when you say, like earlier in here, miss, you had a 6 and then you put the 6, you put the square in the 6 and you become 36. Then can you also do that over here and say, okay, this is 2 over here, And then a negative 5 squared becomes a positive 25, right? And it is already a positive 25, so that means that's not a negative argument anymore. No, because the rule says that it can never have a negative argument. It can never have a negative number inside this parenthesis. And because this happened, regardless of there's a 2 in there, this is not, this is, what is that called? You can't solve it. Hello. You can't solve it. It's undefined, it's an error, and therefore, negative 5 is not part of our final answer. Okay, that's it. And miss, you don't have to do that? No, I don't have to do that because I already know I have a negative argument on the left. That means even if I don't have a negative argument on the right, it will not matter. Okay, last example, number 4. Do they have the same base? Yes, they do. So I can take that and say wrong color, people. Log base of 4 and x squared equals, same thing. And I can just, since they have the same base, I can copy x squared equals 20 minus 8x. Hopefully this is factorable. So minus 20 plus 8x. I always have to do the opposite, okay? Don't forget. So this is, what is this? That line is a very, very, very not straight line. Okay, whatever. So we have x squared plus 8x minus 20 equals 0. Okay, is this factorable? Hopefully it is. So we don't have to worry about doing quadratic formula. Okay, we're looking for two numbers that when we multiply, we'll get negative 20. When we add, we'll get positive 8. Oh, not bad. That would be 10 and 2, right? 10 times negative 2 is negative 20. 10 plus negative 2 or 10 minus 2 is a positive 8. So we are looking for x plus 10 equals 0. It's negative 10. X minus 2 equals 0. That's a positive 2. So we have two values of x's. And we need to check because if it is a negative argument, then we are not allowed to put it as a part of our answer. So left and right. I'm going to copy the original equation and I'm going to plug in, what do we plug in first? 2? Let's plug in 2. Okay. So we have 2 times log base of 4, 2. And again, property says that we can put that as an exponent. So this is log 4, 2 squared, log 4 with log base of 4 of 4. Okay. What about the right? So it's not a negative argument. So we'll need to check if the right side is equal. So log 4, 20 minus 8 times 2. Log base 4 of 20 minus 16. Log base, oh, yay, they're equal to each other. So 2 is an answer. Okay, next. What about negative 10? So we have 2 log base 4 of negative 10. Okay, again, although I could put that in there, but the rule says it could never have a negative in the parenthesis, or the x value can never be negative in there. So this is what we call negative argument. So I am going to stop solving, and I know that negative 10 is not the answer. Okay, there you have it. I hope this video will help you solve for your homework. If you have any questions, please let me know. And thank you guys for watching. I'll see you guys in the next video. Bye!